Good morning, one and all. Myself, J. Anusha, working as lecturer in physics under the department General Section in SS Convent Polytechnic, Zahirabad. And for first year, second sem students, the subject what I'm dealing with is applied physics. And the subject code of applied physics is 18 common 203F. And the main topic what we are going to discuss in today's class is our fifth chapter, that is electricity and measuring instruments from our syllabus. And from this chapter we are going to discuss what is superconductivity. Now to understand this we are using PowerPoint presentation. The main objective of our class is, on completion of our class, you'd be able to understand what is superconductivity and what are properties of superconductors and what are applications of superconductors. Now, before moving on to today's class, let us recall what we learned in yesterday's class. That is, we have studied about meter bridge. Now, what is superconductivity? Now, this property of a material, superconductivity, was discovered in 1911 by a Dutch physicist, Kamerlingh Onnes, for which he got Nobel Prize in 1913. Now, what is the definition of superconductivity? The property of a material by which it exhibits zero resistance at less than critical temperature is called superconductivity. Know that conductivity is our conductor. What it says, it allows flow of current. When a material allows flow of current, when its resistance is very low. Now here we are calling the material as superconductor, or else the property as superconductivity. So we can say that it conducts more, nothing but its resistance is 0. Now when its resistance is 0 at critical temperature, or when the temperature is less than critical temperature. Now here we can understand this property by considering an example of a material called as mercury. When it is cooled below 4.2 Kelvin, it shows zero resistance. What it means? When the temperature is less than 4.2 Kelvin, the resistance of mercury is becoming 0. So we can say that 4.2 Kelvin is critical temperature of mercury. And we can say that this is the property of mercury, which is known as superconductivity of mercury, because its resistance is becoming 0. Now what is critical temperature? The temperature at which the electrical resistance of material becomes 0 is called critical temperature. When the electrical resistance of a material becomes 0, we can say that the temperature is critical temperature. Now what are superconductors? The materials which exhibit 0 electrical resistance below certain temperature are called superconductors. Now here we can see a tabular form which is showing us different materials like gallium, aluminium, indium, tin, mercury, lead, niobium, and we can see different oxide materials. For every material we are having a particular temperature which is known as critical temperature. We can say that for tin it is 3.7 Kelvin. It means below 3.7 Kelvin tin resistance become 0. So these are examples of superconductors. Now let us see what are properties of superconductors. The first property is the resistivity of the superconductor is 0 at less than critical temperature. There will be no Joule heat when current passes through the superconductor. Now as long as the current passes through the superconductor, the material will not produce any heat. Next property is known as Meissner effect. Now what is Meissner effect? It is inside the superconductor magnetic field is 0. So for superconductors, inside the superconductor magnetic field is 0. Next property of superconductor is it shows perfect diamagnetism in the superconducting state. The critical temperature is inversely proportional to isotopic mass of the material. Next, thermal conductivity is low in the superconducting state. A strong magnetic field and electric field and high temperature can be destroying the superconducting state. Now when a material kept in a very strong magnetic field or very strong electric field and or at high temperature, they can destroy the superconducting state of the material. At room temperature, superconducting materials have greater resistivity than other elements. At room temperature, superconductive materials have greater resistivity than other materials. Next property is telling about persistence of current. Current once set up in superconductor continuously flows for very long time. So for very long time we can make a superconductor to behave or else to store current in that material. What are applications of superconductors? Now we can use superconductors in the production of magnetic levitation trains. We can call these trains as bullet trains. As we all know that bullet trains are the fastest trains. So in the production of these bullet trains or magnetic levitation trains, we can use superconductors. Next, in MRI scanning, magnetic resonance imaging, we can use superconductors. And we can use superconductors in switching devices. And we can use superconductors in superfast computers. And we can use superconductors to transfer electric power from one place to another place without any resistive losses. To produce high intense magnetic field, we can use superconductors. And here we can see a particle oscillator which is known as Hadron Collider. In Hadron Collider, we can use superconductors. In the production of sensitive magnetometers based on superconducting quantum interference devices. We call these devices as QUITs. By using these devices, we can produce sensitive magnetometers. So what we have studied or what we discussed, let us summarize. We have seen about superconductivity and what are properties of superconductors and what are applications of superconductors. First of all, what is superconductivity? It is property of the material which shows zero resistance at below critical temperature. Now this is the property of the material, and the material which exhibits this property is known as superconductors. So for superconductors, electrical resistance is zero at a particular temperature. Now these substances have different properties. Now because of the importance of these properties, these superconductors are used in many areas, so that we have seen in applications of superconductors. Now let us see how much we have understood from the from listening this class. So what is superconductivity? Who observed superconductivity? Superconductivity was first observed by Ohm, Ampere, Camerlingons or Schiffer. So as we have seen in the introduction of superconductivity, it was observed by Camerlingons. Next question. In superconductivity, the electrical resistivity of a material become, is it 0, finite, infinite, none of the above? So we have seen this in the definition of superconductivity, that its resistance, electrical resistance is 0. Now superconductivity is exhibited by hydrogen at 4.2 Kelvin, mercury at 4.0 Kelvin, mercury at 4.2 or potassium at 4.2. It is mercury at 4.2 Kelvin. This is what we have seen in the example of superconductivity. The superconducting state is perfectly diamagnetic, paramagnetic. We got both paramagnetic or ferromagnetic. So both B and C are same, and the answer for this question is also the same, that is paramagnetic. What are superconductors used for? Is it for toasters, washing machine, magnetic resonance imaging or water parks? So this is what we have seen in applications of superconductors, that is superconductors are used in magnetic resonance imaging. The ideal superconductors exhibits Meissner effect, mesmeric effect, mesomeric effect, monomeric effect. This is what we have seen in properties of superconductors, that is they exhibit Meissner effect. So this is what we have seen in today's class. So what are frequently asked questions from this topic? So you may get questions like what are superconductors with the example, and what are properties of superconductors, and what are applications of superconductors. This is very simple and very important topic in the chapter, that is superconductivity, because nowadays we are like the every work what we do, that must happen in a quick time. So we can see the flow of current is more in these substances because its resistance is 0. So there is no opposition for the flow of current. So these materials are very much important in different applications in our aspects. So with this we are concluding today's topic, that is superconductivity. Thank you so much. Hope you understood what is superconductivity. As we discussed about superconductivity in the last video lesson, I just want to show you a video which is explaining superconductivity with the help of pictures. Hope you'll understand it clearly. Let us watch and listen carefully.
What is a superconductor? The present age is the age of electricity. We use electricity to light the lights of our houses, streets, etc. Devices like television or a computer, etc. operate with the help of electric current. Thus, electricity plays a very important role in our daily life. When we analyze the devices, which operate on electricity, we find that some amount of electricity is always lost in the form of heat. Let us discuss how. When we analyze the devices, we find that they are composed of vibrating positive ions and free electrons. These vibrating positive ions offer resistance to the flow of free electrons in the form of collision. This causes the loss of energy in the form of heat. Note that about 20% of electricity generated worldwide is wasted due to the resistance of wire and device. So you can imagine how much electricity we can save if we can reduce the resistance of the material. In 1911, Dutch physicist Heike Kamerlingh-Onnes discovered that under certain conditions, some materials do not show any resistance. Such materials that under certain conditions, some materials do not show any resistance. Such materials with zero resistance are known as superconductors. Thus, we can say that superconductor is a material that has zero electrical resistance. Let's now discuss the condition under which the material shows the property of superconductivity. When we keep decreasing the temperature of a material, we see that the free electrons stop colliding with the ions. As a result, the resistance of the material also decreases to zero, and it starts behaving like a superconductor. The temperature at which the electrical resistance of a material drops to zero is called critical temperature. Let us now analyze the behavior of a superconductor when placed in a magnetic field. When we place a superconductor in the magnetic field, we see that the magnetic field bends around the superconductor as it is not able to pass through it. Thus, the superconductor behaves like a perfect diamagnetic material. Now, if we keep increasing the intensity of the magnetic field, we see that a stage comes when the magnetic field penetrates through the superconductor, thus destroying its superconductivity. The magnitude of magnetic field at which the superconductor loses its superconductivity is known as the critical magnetic field for a superconductor. It is
electricity. Hey guys, welcome to SkillLink. The invention of electricity changed our lifestyle, and it has become an integral part of our life. We depend on electricity for so many jobs and cannot pass a day without it. You might have noticed electric equipment getting heated up after prolonged usage. This heat is generated because of electrical resistance. This implies that there will not be a loss in the form of energy when there is no resistance. But are there elements that exist without electric resistance? Well, you'll get to know the answer in this video. In this video, we're going to discuss what is superconductivity, what are superconductors, their properties and applications. So let's get started. Materials can be divided into three main categories based on their electrical conductivity. There are conductors, which conduct electricity, and insulators, which do not. Then we have semiconductors that can be made to conduct electricity. The conductivity of a material is due to its internal structure. In a conductor, the electrons are loosely bound to the nucleus so that they can move easily when there is a potential difference. But as the temperature increases, the positive ions in the conductor start vibrating due to thermal stresses. This in turn interrupts the flow of electrons, that is, it resists the current flow. It is noted that the increase in temperature increases the resistance of the conductor. Studies were also made to check if there are any materials that exhibit zero resistance by lowering the temperature. In 1911, a Dutch physicist named Heike Kamerlingh-Onnes discovered that mercury at a very low temperature of 4.2 Kelvin conducted electricity with almost no resistance. Following this, some other materials that also conducted electricity with zero resistance when they are at extremely low temperatures had been found. This phenomenon by which materials possess zero electrical resistance at extreme cold conditions is known as superconductivity. And the elements that exhibit this property were called superconductors. The temperature at which a conductor turns into a superconductor is known as the critical or transition temperature, and this varies from conductor to conductor. Now let's see how superconductivity actually happens. Though the phenomenon was found in 1911, the reason behind that remained unknown for years. However, in 1957, three scientists named John Bardeen, Leon Cooper, and John Robert Schrieffer came up with a theory called BCS theory, which explained the phenomenon of superconductivity. Let's see what the theory says. Consider that we have a superconductor. Due to the extreme cold condition, the molecular vibrations are negligible. For instance, let's take a single electron which travels towards the positive terminal through the positive ions. As the electron moves, the positive ions are attracted towards it because of the opposite charge. This in turn results in the accumulation of positive ions in a place, for instance. This increased positive charge attracts secondary electrons towards it. That is, the electrons form a Cooper pair bound together by a weak bond. The Cooper pair is bounded over a long distance and moves together towards the positive terminal. The number of Cooper pairs overlap each other and move together between the lattices without causing any disturbance, resulting in zero resistance. Because of the zero resistance, the current can flow in a superconductor loop even after the source is removed. Apart from zero resistivity, superconductors also have a significant feature. A superconductor is completely diamagnetic as it expels magnetic fields. That is, when a normal conductor is placed in a magnetic field, the magnetic lines pass through it. But superconductors repel the field and it will not have any magnetic field inside it. This effect is called the Meissner effect, and because of this, superconductors are used in levitating trains. The fast-moving maglev train consists of superconductors on its base which repels the magnetic tracks. This ensures fast movement with minimal power loss. But superconducting property is not permanent. The material can lose its superconductivity when a large current or another magnetic field of high intensity passes through it. The minimum current density at which a superconductor turns into a conductor is known as the critical current density, and the minimum intensity of magnetic field at which the material loses superconductivity is known as the critical magnetic field. So far, we've talked about superconductors that are categorized into type 1 superconductors. But there are also some materials that exhibit superconductivity at a high temperature. Those materials are categorized as type 2 superconductors. However, the reason behind the superconductivity at high temperature is still largely unknown. Preferred mainly because of their zero resistance, low power loss, and capacity to produce large magnetic fields. But the major disadvantage is that they cannot be used in ambient temperature. When it comes to applications, superconductors play a vital role in so many applications. They are used in MRI scanning systems, computer parts, particle oscillators, power transmission elements, power storage elements, etc.